Open the road design drawing. When we view a corridor in Civil 3D, we are seeing the result of joining up the link codes and the point codes from the assemblies we've used. These two white lines represent the link codes from the pave links on the assembly. If we add these lines to a surface as break lines, you can see that Civil 3D will triangulate between the lines forming a surface. Looking again at the assembly, all of the points are also coded. When the point codes from adjacent assemblies are joined together, they form lines. These are the corridor feature lines. There will be a feature line for each point code. These are represented by the blue lines in the top viewport. If we add these to a surface as bright lines, then again we'll get a triangulated surface. So we have two ways that we can create surfaces from a corridor by using links or by using feature lines. The links on the top of the sub-assemblies generally have two codes. For example, the curb is coded as curb, but the top links are also coded as top. And it's the same for the road lane, it is coded pave but also top. So we could add links to our surface from individual sub-assemblies using the codes curb, pave, etc. But we could add all the links on the top of the corridor in one go by using the top link codes. Similarly, the bottom of the sub-assemblies all share a common code of datum. So to create a corridor formation surface we can use all of the datum links. On our site we have our RD corridor, but we need to allow access to our house garages. We need some driveways. These white polylines in the drawing represent the positions of the driveways. We need to add these in our corridor before we create our surfaces. The super assembly we imported for the curved version footpath can adapt to add a driveway with the dropped curb when it detects a driveway target has been added. All of our driveway polylines are on layer C-road-dr targets. We're going to add these to the corridor. Pick the corridor from the Modified Region panel of the Corridor Ribbon tab, click on Edit Targets. Select the region and in the Target Mapping dialog we're going to add the driveways to the driveway target on the right side of the road. Click in the Object Name column for the width or offset driveway target. In the Target dialog, set the object type to Feature Lines, Survey Figures, and Polylines. We can add all of our targets in one go by using Select by Layer. In Select Entities by Layer, scroll down to the C-RD Doctor Targets layer and select it. Note there are 7 objects on this layer. Click OK and then OK again to dismiss the Target Mapping dialog. The corridor will rebuild and the driveways are added to the corridor. If I view the corridor and the object viewer, you can see the result of adding the driveways. Notice how the drop curve has been added for the driveway. Now we can create a surface for our corridor. Select the corridor and on the Modify Corridor panel, select Corridor Surfaces. In the Corridor Surfaces dialog, use to create surface button on the left to create a new surface. Rename the surface to Sycamore Heights Top Surface. In the At Data region at the top of the dialog, set the data type to links. And from Specify Code, select the top link codes. Click the Add button to add them to the surface. For the surface, select Add as Break Line. And set the overhang correction to Top Links. Set the surface style to Contours 1 foot and 5 foot design. Create another new surface and rename it to Sycamore Heights Datum Surface. Set the surface style to triangles. Add the datum link codes to this surface. Select Add as Break Line and set the overhang correction to bottom links. If there should be two overlapping links, both coded datum, then the surface will use the lowest link of the two. Click Apply and rebuild the corridor. We may not see the result of the surfaces until we refresh the display. Click OK and then run the Regen command. You can clearly see the datum surfaces as triangles in the model. Note the surfaces have been added to the Surfaces collection in Prospector. Use Prospector to select the Sycamore Heights corridor. Over on the right-hand side of the corridor you can see there are triangles that have been created outside of the junction area. To remove these, we need to add boundaries to our surfaces. Select Corridor Surfaces from the Modified Corridor panel. In the Corridor Surfaces dialog, select the Boundaries tab. Right-click on the top surface to add a boundary. Corridor Extends as Outer Boundary will attempt to detect the boundary automatically. Add Interactively can be used if the first option fails. This will require you to manually select bounding feature lines from the corridor. Add from Polygon can be used if all other options fail. You'll need to create a polyline and add it as the boundary. Select Corridor Extents as Outer Boundary. Repeat this for the datum surface. Click OK and rebuild the corridor. Zoom into the corridor and pick one of the contours on the corridor top surface. Review the surface in the Object Viewer. You should be able to see the driveway drop curbs in the surface. Pick one of the triangles representing the datum surface and review this surface. This represents the formation surface of the road. You can clearly see the different depths of construction used on the road, curbs and driveways. Use the surface properties of the datum surface and set its star to No Display. Now we're allowed surfaces to the McAllister Boulevard corridor. Select the corridor and click on Corridor Surfaces from the Corridor Ribbon tab. Add a top surface as before. Adding the top links and selecting Adder's Break Line and setting the overhang correction to top links. Set the style to Contours 1 foot and 5 foot design. Go to the Boundaries tab and add an outer boundary. Then click OK and rebuild the corridor. Use Regen to refresh the display. Select the new top surface and review it in the Object Viewer. The surface looks fine until you zoom into the lay-by area. Here you can see the curves have not been modeled correctly. This problem occurs when sub-assemblies from different baselines in the corridor overlap slightly at their edges. Go back to the corridor surfaces for this corridor. Select the surface and from Add Data set the data type to Feature Lines and add the codes Back Curb, Flow Line Gutter, and Top Curb. These are all point codes on the curb. Click OK and rebuild the corridor. And review the surface again. Adding the feature line codes has improved the surface and the errors have been fixed. Once all of the corridor surfaces have been built, I could share them with other models in the project by creating data shortcuts. I will select the surfaces and corridors and add them to the Data Shortcuts project. We've seen how we can create surfaces from our corridor models and share them together with the corridors as data shortcuts. We can now use these surfaces for cut and fill analysis and to create a finished ground model. Civil 3D surfaces can be used to calculate volumes of cut and fill between two surfaces. Generally, this is between a design surface and an existing ground surface. We can create a tin volume surface using the surface creation tools and set our base and comparison services. However, we often need to assess multiple design surfaces at the same time. The Volumes dashboard on the Analyzed Ribbon tab allows us to do this. We'll want to adjust our surfaces to optimize the amounts of cotton fill while still maintaining our design standards. We can edit the road profiles used in our corridor models and update the volume surfaces automatically. The start of Sycamore Heights is controlled by our intersection with McAllister Boulevard. We will need to set this to rebuild whenever a design change is made. Select the intersection in Prospector, right-click and select Update Regions automatically. Choose Continue with Update when the warning is displayed. The intersection will be rebuilt. Next, select the Sycamore Heights corridor in Prospector. Right-click on it and select Rebuild Automatic. Both the intersection and the corridor will now rebuild when they need to. From the Analyzed Ribbon tab on the Volumes and Materials panel, open the Volumes dashboard. In the Volumes dashboard, the panel on the left will show the total site volume. To turn this on, click on the Toggle Net Graph button on the top left of the dashboard. Now we'll create a volume surface for the road. Click on the Create New Volume Surface button as shown. For the name, use Fall to Sycamore Heights datum. Set the style to Cut and Fill banding 1 foot interval 2D. The base surface is always the existing surface, in our case existing ground. The comparison surface is always the design surface. This will be Sycamore Heights datum surface. Click OK and the volume surface will be added to the volume dashboard. It has calculated a net volume of nearly 12,000 cubic yards of cut. This means that our profile for the road is generally too low. If you pick the profile, you can see the two crests curves are very close together. To be able to adjust the profile, we'll need to reduce the lengths of these curves. Use the grips on the curves to make them both shorter as shown. This will provide some space between the curves for them to move freely. At the start of the profile, you can see the change of grade at the intersection. If we alter the first grade on Sycamore Heights, there is a possibility that the dynamic intersection will add a new tangent. We want to avoid this, so review the rules for the intersection. Right-click on the intersection in Prospector and select Adjust Side Road Profile. The rules show that the maximum gradient of the intersection is 5%, and the maximum change in grade is 4%. Since the crossfall on the main road is at -1.94%, this allows us a maximum grade of 2.06% on the incoming tangent. Right-click on the profile and select Edit Profile Geometry. On the Profile Layout tools, open the Profile Grid view. In the grid view, set the grade of the tangent in the grade out column to 2.05 as shown. Since we know we can't raise that tangent or its intersection point, then we must use the PVI of the second curve to adjust our volumes. Using the grips on the profile, pick the PVI grip and drag it U. After the corridor has rebuilt, go back to the volumes dashboard by switching tabs in the panorama viewer. Use to recompute volumes button to refresh the volume surface. I still have a net cut of 1963 cubic yards. You'll have different values depending on the edits you've made. You can repeat the adjustment to the profile to reduce the net volume as much as you can. I'm going to edit the profile again and then go back to the profile grid view. I want to reset the K value of the curve I've changed back to 151. Close the Profile Layout tools and the Profile Grid view. Reopen the Volumes dashboard if it is closed. Use the Recompute Volumes button to refresh the volume surface. In our example, we now have 1052 cubic yards of fill. Again, your volume will be different depending on the changes you've made. You can readjust the profile as before to reduce the net volume even further. Now we'll update the surface style to display our cut and fills. In the model, pick the blue volume surface. Right-click and select Surface Properties. In the Surface Properties, go to the Analysis tab. The analysis type should be set to elevations for the legend. Select Cut and Fill Volumes. For the ranges, select Range Interval with Datum. The interval will be 1 foot and the datum will be 0. Use the Run Analysis button to generate the ranges. Cut areas will be displayed in reds and the fill areas will be displayed in greens. Click OK. We can now see visually where the cut and fill takes place on our road. A groundworks contractor could use a drawing of this to plan where to dig and where to place the cut material. Select the volume surface and on the Surface Ribbon tab Labels and Tables panel, select Add Legend. On the command line, choose Elevations for the table type and then choose Dynamic for the table behavior. Select a position for the legend table in the viewer viewport somewhere clear of the design. The legend displays the cut-fill depths with the color and 2D area and the volume for each color band. Finally, in this example I have added all 3 volume surfaces, one for each corridor, to the volume dashboard. The total net volume for all 3 roads is shown as 43,000 cubic yards of cut. The volumes dashboard allows me to trade volumes across all 3 corridors. It may not be possible to raise one RD because of design constraints, but I might be able to raise one of the others to compensate. After making some more edits to my corridors, I've been able to reduce the volume to 18,178 cubic yards of cut. We have seen how we can use volume surfaces and the volumes dashboard to optimize our RD design. Using the volume surface style, we can display a cut and fill analysis graphically, and the legend adds detail to our analysis. We've created our RD corridor models and created corridor top and datum surfaces from the models. We're now going to create sample lines along the corridor baseline alignment so that we can create some section views of the road. From the Home ribbon, Profile and Section Views panel, choose Sample Lines. On the command line, it's asking you to select an alignment. Press Enter to select it from a list and choose McAllister Boulevard. Click OK. When you move the crosshairs in the drawing, it's anchoring a line perpendicular to the alignment and is expecting you to pick the stations where you want to place a sample line. We don't want to create our sample lines in this way. We can see here on the Sample Lines toolbar that each sample line has a name, which in our case will be set to the station value of the sample line. And there is a group name which will be assigned automatically. The Alignment Picker button allows us to change the alignment we are using. The pull-down list on this button allows us to create a new sample line group. To edit the default options for the sample line group, such as the name and the surfaces and corridors to be sampled, we can delete a group. Select a group from the drawing. We can edit the swath widths for the group. And we can add more sources for sampling. Using the Sample Line Creation Methods button, we can choose how we want to create the sample lines. You can choose by range of stations. We can choose an individual station. We can set our sample lines to match our corridor frequency. We could pick points directly on the screen. And we can use polylines that have already been created in the drawing. Choose by range of stations. In the Station Range dialog, we can set the start and end range stations for the sample lines. Set the From Alignment Start value to false and then set the station value to 0. Here we can set the left and right swath widths. Change the swath widths to 100 feet on the left and on the right. We could also use offset alignments to define the widths of the sample lines. Here the sampling increments allow me to set the frequency of my sample lines. Increment relative to is currently set to absolute station. We can keep that set to absolute station and we will have sample lines at even 50 feet intervals. We can generate sample lines at the start and end of the ranges and also at geometry points. And super elevation critical stations if we have super elevation generated on our alignment. Set at range start and at range end and at horizontal geometry points all to true. Click OK. Now press Enter to accept the sample lines. You can see the sample lines have been labeled in the drawing with their station value. When you select a sample line, you'll see the grips are enabled on the line. Sample lines are dynamic and if you edit a sample line then any section views generated will update automatically. The diamond grip will allow you to drag the sample line along the alignment. Using the arrow grip you can change the swath width of a sample line. And using the square grip you can make it non-orthogonal if you wish.